All right, in this video we're going to discuss conditionals. When you're writing programs, you might want to write some conditionals. And a conditional is basically logic. It's saying, if something, if some condition, then do this. And so we use if statements or if-else statements. And the basic format of it, so I'm going to come down here in my function that we're going to run, and I would start with if, and then I do some parentheses, and then I have a condition, some kind of a condition in the parentheses, and then I do an open curly bracket and then a closed curly bracket. So this structure here is basically an if statement, and I'm going to put a condition in here, and if the condition is true, then it'll execute any code that's in this in these particular brackets. If the condition's not true, it'll skip all this code and go on down here to some code down here. So, so an example of this would be like, let's go ahead and set up some kind of a variable. We'll do number equals 5, we'll say. So we have a number that's equal to 5. And so what we want to do is and maybe we don't know really what that number is. That number is being fed into this function from somewhere, and we want to check some things about this number. So we might do a condition that if number is equal to 5, then we will go ahead and execute some code. So the way I do that here, and this is really important here, and this is hard, this is going to be a trick that people can get confused on. If I want to say number equals 5, the way you'd normally think to do it would be say if number equals 5. It'd be very simple. The problem is that we can't do that. We can't use one equal sign. One equal sign has already been used in most programming languages to assign a number to a variable. See, we used it up here. We said set number equal to 5. So one equal sign is what we call the assignment operator. We're going to assign some number or text or whatever to a variable. We use one equal sign. If we're checking, doing a conditional to see if some variable equals something, then that is two equal signs. And that will cause you problems. You will have code that doesn't work, and you'll get errors, and you'll have to remember that, oh yes, one equal sign when I'm assigning a variable to something, two equal signs if I'm checking to see if something equals something. So, it's really important equaling here. So if I want to see if something equals if some variable equals something, then I need to, in the condition, I need to put two equal signs. So I could do if number equals 5, and then I could do some kind of a code here. I'm going to go ahead and I'm going to print it to the screen, so we'll use our logger again. Logger.log, and I'll type in some text here. Logger.log, yes, the number was 5. Okay, and I'm going to actually take this, and I'm going to also copy it down here outside of this conditional, and say, no, the number was not 5. Okay, something like this. So if I run this right now, the number is 5. So when it says is the number 5, if the number is 5, then print this. Okay, and then go on. If it's not 5, right? If this number is something else, then it's going to say is the number 5, and it won't be. So it'll skip this code and it'll go down and run this next code. So if we run this, and then remember we can do Command R instead of hitting the little button up here, but we also hit Command Enter to do our log, and we'll see that it says yes, the number was 5, but then it says no, the number was not 5. Why did it do that? Well, it was 5. So when it asked this question here, it said yes, and so it printed this, but see, then it went on to the rest of the code, and then it did this. So what we might want to do is we want to run the code. Well, before we do that, let's try something else. Let's say that we change the number to 3. Okay, so now what should it print? Well, it says if number equals 5, then print this. Well, it doesn't equal 5, so it's not going to print. It's going to actually skip this code. And then it'll go on, and it'll, of course, it'll print this code down here. So if we run that and we do our log, all it says is no, the number was not 5. All right, so let's go back to making it 5 again. And so what we want to do is we want to say if the number is 5, print this. Otherwise, print this. So we don't want it to just keep going and print this no matter what. So how do we do otherwise? Well, we do what's called an else. So if this condition then is true, then go ahead and print this. And then we'll do else. And then, of course, we do an open bracket and a close bracket again. So here's the structure. We have if condition, do this code in these curly brackets, else do the code in this curly brackets. Hope that you see how that works. So number equals 5. So if number equals 5, print this. Else, print this. So if we run that and log that, it says yes, the number was 5. Well, let's go up here and let's say that the number, let's change the number to 3. And let's run that. No, the number was not 5. Okay. So we can use if and else statements. We can also do we can do more than that. We could do else if. So I can do actually a new condition. I could do if number equals 5, logger.log, yes, the number was 5. Else, I could do else if number equals 3, then I'm going to say logger log the number, I'll say the number was 3. Okay, I'll come up here and say the number was 5. Okay. So if number equals 5, I could do logger.log the number was 5. Okay. Else if the number equals 3, then do this. Okay. And what if it's not 3 or 5? Well, it's going to not run this code, and then it's not going to run this code, and then it'll just keep going. So what I might want to do is I could do, maybe I want to print something if it's not 3 or 5, and so I could do another else. And I could open up that code and close that code, and then I could say something like the number was not 3 or 5. So this is if stuff, else if this, more stuff, else this stuff. So I can kind of compartmentalize what I want printed to the screen depending on the conditions. So if number equals this, then do this. Else if number equals this, do this. I could do another else if some condition, do this. Else if some condition, do next. Otherwise, and then eventually I end with kind of just an else. Whatever's left over, print this particular thing. So I can run that, and right now remember the number is 3, so it says the number was 3. It came in here and it was not 5, so it didn't do this. Came in here, the number was 3, so it did do this. And therefore it will never go on to do this because it met the condition right here. I could put 5 in here and run that. And then it says that the number was 5. I could come in here and put in 2. What's it going to do now? I run this, and it says the number was not 3 or 5. So this is if, else types of conditioning. Okay, let's go ahead and delete off this else if stuff, and let's go back to the number thing again. And let's look at some other things we could do. I could, you can do, this is making it equal. I can do less than. So if the number is less than 5, then, and the number is 2 right now, so if the number is less than 5, this would work, and it would go ahead and print out this statement. We can use greater than, if you got to remember how they go. So remember, this is greater than symbol is, the alligator, eating the bigger thing. So if number is greater than 5, then it would print this out. This code, of course, would not print this out because right now the number is 2. So number is not greater than 5, and it'd go that. What if we want to say the number is greater than or equal to something? So that would be greater than and then an equal sign. So the way you say it, greater than or equal to, so you just write the greater symbol, then the equal symbol, and I could do like 2, and this would actually work because the number is 2, it's greater than or equal to it, and it'll go ahead and print this out. So I could put 2, I could put 3, I could put 4. Any of those is going to make this one be true. What about less than or equal to? Well, I'd do the less than symbol and then equal. So I could do less than or equal to also. What if I wanted to say not equal to? I might want to just say that. Like, what if number is not equal to 4, then run some kind of code. And otherwise, always run some other code if it happens to be 4. So I could do the not symbol is very strange. The not symbol is actually an exclamation point. So I would do not equal. So an exclamation point is not. So number is not equal to 2. Then I would do something like this down here. Okay. So right now, if I ran this, I'll just run this one right here. It says the number was 5, which of course that's just what my text says. So anyway, the point is that it ran the code because the number is not equal to 2. It's actually 4. So it ran this code. So you can use not equal also. You can do more than one conditional. So like let's say I wanted, so if the number is less than 2, okay, I could do if the number is less than 2, or number is greater than 5. I could say if number is less than 2 or number is greater than 5, and I could try to run that, and ooh, it doesn't work. There's an error, and the error is because you can't just use the word or. Sometimes you can use the word or in various languages, but in JavaScript or Google Apps Script, you can't use or. You use a different symbol, and that symbol is 2 what we call kind of pipes, straight up and down symbols. You can find them above the backslash symbol on your keyboard. So if number is less than 2 or number is greater than 5, then print, something, in between, I guess. Or no, it wouldn't be, it'd be outside. It'd be outside of those two numbers, right? If number is less than 2 or number is greater than 5. Okay, so what's this going to do when I run this one? The number is 4, so that is not less than 2, and it is not greater than 5, so it probably shows no logs. Right, okay. If I make this like a 1, and I run that, then it'll say, yep, it was outside. Or if I make this a 6, and I run that, it'll say, yep, outside. And I could do number less than or equal to 2 and number greater than or equal to 5. So anything 2 or less or 5 or more, it would work. I could also do what if number is, what if number is greater than 2, and I want it to say and. What if the number is greater than 2 and the number is less than 5? So, what would work for that? Well, 3 or 4 would work for that, right? So if the number is greater than 2 and number is less than 5, then we'll print, inside the two numbers. And I'll try to run that, and of course it doesn't work again. How come? Because we can't use the word and. So the words or and can be used in some languages. In JavaScript it's not. Remember, or was the 2 pipes. And is a little bit easier to remember because there is an and symbol, right? And it's 2 of those. So you take 2 and symbols, and that means and. So if number is greater than 2 and number is less than 5, then print this inside. I can run that, and I can, and that didn't work. Add logs to your project. Okay, so if, oh, that's because my number was 6, so it did work, right? 6 is not greater than 2 and less than 5. Now, that's important to keep in mind there. You got to understand logic. 6 is greater than 2. Right? It is greater than 2, so that part's true. But this is and. Number is less than 5. And this and means both of these conditions need to be met for it to print. So although 6 is greater than 2, it is not less than 5. I could put in 4, and I could run that, and now it works. I could also do a 3. That should also work, right? And it does. I put a 2. Number is not greater than 2 because it's actually equal to 2. And number is less than 5. It is less than 5, but it's not greater than 2. So if I run this, I get no logs found. Okay, so those are all kind of your comparison, your conditional operators that you, and there's other things, but that's generally all the ones we're probably going to use. So let's try to do let's do a little program here. Let's make a little grading program that we're gonna get a percentage, some grade percentage, and we're going to print out to the screen, to the logger, what that grade is, something like that. So let's set up a variable called grade, and let's do a random grade, something from 0 to 100%. Okay, because this is a good time to remind ourselves, because you're going to need to know how to do this a lot. How do I get a random number? Well, that's a math function. So I do math dot, and it's random. There it is right there. See, random. Okay, and two parentheses like this. So math.random. And if you remember, we had this in an earlier video. Math.random gives you a random number from 0 to 1. So it's like a dot, a whole bunch of things. So if you want to do bigger ranges of random numbers, like maybe from 1 to 100, you need to actually multiply it by the number you're wanting to do. So if I do math.random times 100, now that's going to give me a random number from 0 to 100. Okay, now the problem with that is it's going to be, it's going to be a lot of decimal kind of thing. In fact, let's just show what that looks like here. So we're going to log grade. What is grade there? Oh yeah, I don't need. Okay, I'm just going to get rid of this right now. Okay, so let's run this, and we'll see a random number, 4 point, a whole bunch of stuff, right? So I'll run it again and log it again, and now I got 57 point and a whole bunch of stuff. So what we want to do is we want to cut off all this stuff so that I just have these first two, an integer basically. And if you remember how to do that, we did that earlier too. That's a math function called floor. Basically, it cuts everything off here and just floors it down to whatever this particular thing is. So I'm going to put this random thing in a floor function. So I would do math.floor, and I put parentheses around this whole thing here. Okay, and now if I run that, I get 8. And if I run it again, I get 35. And I run it again, and I get 10. Okay, so that's a lot better. So that's how you're always going to do that, by the way. So memorize this thing. So math.random times whatever you want to have a random in between, like 0 to 1. I just, math random, I just do it normal. If I wanted to go to 2, I'd do math random times 2. And then I'm going to put that whole thing in a floor function, so I just chop off all the excess stuff. Okay, so now I want to do some if statements to figure out what a grade would be. I'm going to go ahead and set up another variable called letter for the letter grade, and that's going to be a string. So I'm just going to go ahead and set it up as a string right now. So it's an empty string, so I don't have to do the var every single time. Okay, so I'm going to start doing some if-else statements. Is what I'm going to do. So I'm going to start with if, and my condition will be if the grade is, and we'll just keep this easy, we'll just do straight grades, we'll avoid the plus minus stuff. So if grade is greater than or equal to 90, greater than or equal to 90, there's my condition. So what am I gonna do in that? I am going to assign a variable to the letter. If its grade is greater than or equal to 90, then letter, and see I don't have to do var anymore because I already defined it up here. Letter equals an A. Okay, so if grade is greater than or equal to 90, letter is going to be an A. Else if, and my new condition is grade is greater than or equal to 80. See, I just start cutting things off here. So when it first goes through, it's going to first check, is it greater than 90? If it is, put an A. And then it'll skip every other thing, see, and that'll be it. But if it's not, then it's going to go to the next one. Is grade greater than 80? And then it's going to put, it's going to put a B here. So I can actually just kind of copy this here and do this and do letter B. So if it's greater than or equal to 80, it's going to have a letter B, and then it'd stop there, and it wouldn't do any of the rest of the stuff. So I'm going to keep on doing that here. I'll just copy this section here, and so that's a B, and then I would do a C, and then I would do a D, and then I would do an F. So if grade is greater than or equal to 70, if grade is greater than or equal to 60, if grade is greater than or equal to a 70, we're going to say that's a C. If it's greater than or equal to a 60, we're going to say that's a D. And then what do? Well, if it's less than 60, right, that's bad, right? And we have weird distorted grading scales where 60% of it is actually an F. So if it's less than 60, we know what it's going to be. It's going to be an F. So if it went through all these conditions and it still hasn't been met, then we don't really need an else if. All we need is an else. We just need, okay, everything else. So else letter is going to be an F. Okay, so let's look at this again. If grade is greater than or equal to 90, put an A, and then it would stop. It wouldn't do any of the rest of this. If it's not, then it's going to go on to the next one. If it's greater than or equal to 80, it's going to do a B. Greater than or equal to 70, C. Greater than or equal to 60, D. If it still hasn't met any of those conditions, then there's only one other option. So we don't need to do any more ifs. So we'll just do else, make letter B an F. Okay, so then down here, what we can do now is we can log something. Let's log some text. Let's concatenate some stuff together. So we can say text, your grade is text, and then remember we want to concatenate strings and variables together. We use plus signs. So there's my string in quotations, and I'm going to do plus, and then I'll do whatever the grade is, plus, and then I'm going to do a space text. I'll do some text with a space in there, plus, and then I'm going to write the letter, what the letter is. So your grade is, and I'll do something, actually, you know what, I'll right in here, I'll do a percent space, yeah, so like it'd be like a 80%, and then what the letter is. All right, let's run this function and see if I get any errors. No errors, how about that? So I log it, and it came out to be a random 71%, and that was a C, so it worked. That was great. You probably should test it several times. That was really lucky, actually, because it's random, so 60% of the time we do this, we're going to have an F on this. So let's run it again and log it. Ooh, an A, nice. Run it again. B, man, we're really lucking out here. We're like defying the odds. There we go, there's an F. And we'll run it again, and there's a C. Run it again, there's another F. If we do this a lot of times, of course, you're going to get a lot more Fs than you'd like, probably. So, okay, so we can actually do a grading program. Eventually, the importance about these functions is we're not going to actually, hard code in some kind of thing. We're actually going to pass something to this function right here in this little spot here, and we're going to be talking about that in future videos. Okay, one last thing I want to do here. I know this video is getting way too long, but one last thing I want to do is I want to look at some Booleans here. So I'm going to delete this, and we're going to set a variable, and we'll call it done, and equals, and remember Booleans are true or false, not capitalized, by the way, in this syntax. So I'm going to say done is true. Okay, I'm going to set that variable, done equals true. And then I'm going to do an if. So I'm going to do if, and let's say I want to know if done is true. So I would do if done equals true. Okay, and then I want to do something. So I could say I could do yes, it is true. We'll do that. And then I'm going to do else, 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 no, it is false. Get rid of this down here. Don't want that. Okay, so I have a variable called done. I'm setting it equal to true. I do if done equals equals. Remember, equals equals true. Then it'll print yes, it's true. Else it'll print no, it is false. And we can run that. And I'll do it, and of course it says yes, it is true. Okay, I think you could have done that. That's not a big deal. So the reason I'm showing you this is because when we're doing Booleans, there's kind of a little shortcut method. You don't actually need to do if done equals equals true. You can delete that equals equals true. And if it's a Boolean type variable you're dealing with, this just says if done. And what that really means is if all I'm doing is if and I have the, just the variable alone, that means if done, the variable here, is true. If it means it's true, then go ahead and do this. So I can take that equals equals true out, and I can run that code, and it'll still work. It says, yes, it is true. What if I change this to false? What if I change this to false? So now it'll say if done, and that means if this is true, then you do this, else it's going to be doing this. So if I run this, I get no, it is false. So that's a little shortcut thing, but sometimes it's hard for people to remember what that really means. And if you want to just go put out done equals equals true, then I guess you can. So that'll be fine. So what if I do, let's set this back to true. And if I run this, of course, now it's going to print this. What if I do this? What if I put a not symbol in front of that? If not done, what's it going to do? We run that. It's going to say, no, it is false. Because really what that's doing is saying if, and the conditional is saying is done not equal to true. That's what that's meaning. If done is, remember, if I didn't have the exclamation point, it was just done. So it meant is done equal to true. But now this means is done not equal to true, which of course would mean it's false, right? So if done is not equal to true, okay, then it's not going to run this. It's going to run this. It's because done is actually then, false, right? So if done is not true. So if I run this, it says no, it is false. Okay, it's because so if not done, then I would have to come down here and do this. Okay. All right, so that's a little confusing, but I thought I'd just throw that out with Booleans, and that is how you do conditionals, if, else types of statements, and you'll find that syntax in pretty much every programming language that you ever learn. It might look a little different, but generally that's how we do conditionals. All right, this video is going to be extremely important. This is going to show you how you can loop, which means how you can do a section of code like over and over and over and over and over again and run the whole thing. And so it's, if you're going to go into computer science and you're going to learn how to do coding languages and stuff, looping is obviously very crucial. So the loop we're going to look at here is called a for loop. So in my function, the way the structure looks like for a for loop is you type for, and then you have some parentheses, and we're going to have some maybe complicated stuff in there. And then we're going to do open curly bracket and then a closed curling bracket. So it's going to give some kind of conditions in here, and it's as long as those conditions are still true, it's going to keep going through this a specified amount of times. It'll run this code over and over and over and over again. So what's in the for loop? Well, there's actually 3 statements that are in the for loop. 3 statements. The first statement is to set up a variable, and it's going to be like a counter, and that's going to mean like how many times you're going to go through this particular loop. So the way we set up a variable is var, right? And I'm going to do, I'll do a variable called maybe counter, var counter, and I can set it at where I want it to start from. A lot of times we start it at 0 because we're kind of 0 based, start with 0 in our counting numbers. I could start it at 1 though if I wanted to, but I'm going to start it at 0 because that's kind of normally the tradition we do. So there's our first statement, so I need to do a semicolon behind it. So var counter equals 0. So I set up a counter equals 0. My next statement is a conditional, like we just learned about in the if-else statements. So I'm going to do but I don't have to do any if here. It just this for loop knows what we're trying to do here. So I'm going to say, basically if, but I'm not going to write it. Counter is less than less than 10. And you can, again, you could use less than or equal to, or you could use, whatever. So I'm going to do if counter is less than 10, and then that's another semicolon. And then the third statement is, and so this basically means this number right here is really how many times it's going to go through this loop. It starts at 0. And every time it goes through the loop, it's going to start counting up, and we'll show you how we're going to do that here. And when a counter is less than 10, it won't go into here; it'll stop. Now, what does that mean? That means when it gets like to 9. So, but that's still 10 times because remember the first time was times 0, up to 10 times 9 would be 10 times. So as long as I start the counter at 0, and I whatever number I put in here is how many times it's going to go through the loop. If I actually put this counter at 1 and I wanted to go through it 10 times, I'd have to actually do counter less than, 11. So you take this and subtract this, and that's how many times you're going through the loop. As long as this is just less than. If this is less than or equal to, well, now it's going to go through, 11 times. It's going to go 1, and it's going to go through even when it's 11. Okay, so I'll go back. Hopefully, maybe that makes sense. You have to experiment around with this. So I start my counter at 0. I'm going to go until it's less than 10, and then the next statement is going to be how are we going to increment this every single time? How are we going to increment it? So I'm going to do a counter equals counter plus 1. Now in this last one here, there's 3 statements, but this last one we don't put a semicolon after. This is kind of like something that's happening after each time of the loop. So we put semicolons after the first statement, the establishing the variable. We put one after the conditional here, but we don't put one out after this one. Now, there's some ways that we make this all look a little different. So if you are familiar with languages and actually the for loop, then you're probably all looking at me thinking I'm an idiot for writing it all out this way. But so here's kind of the shorthand method. Generally, you can use any variable you want here. I use counter, but we don't usually use that. We use something a lot shorter. In fact, we usually always use kind of just the way people do it. You don't have to, but it's kind of the way people do it. We use a counter and we call it I. So we set up a variable called I, and then of course that means this is I less than 10, and then this means this is I equals I plus 1. So if you notice, that makes everything look a whole lot shorter. We even go a little bit shorter on this. If you remember this right here, when I take a variable and I take the variable plus 1 and add it to that variable, if you remember, there's a much shorter way of doing this. If I want to just increment this by 1, there's a couple ways I could do it. I could do plus equals 1. So this actually just adds 1 to it every single time. Okay. The other way, which is even shorter for this one, is I plus plus. So an I plus plus, remember, will increment it by 1 each time. An I minus minus would decrement it by 1 each time. Okay, so here's our kind of how our for loop is set up. So it starts with 0. It's going to increment it by 1 every time through the loop, and then it's going to go until it gets to, when I equals 9, it's going to go through here again, and then it comes back, and now I is 10, and it comes in here and says, nope, I is not less than 10, because it's equal to 10, and it will not do this anymore, and it'll go down here to do the rest of the code. Okay, That's how a for loop works. Hope you have each of those little sections kind of figured out and what they're doing. So then inside the brackets, I can do whatever code I want. I could write almost a whole program inside there, and then iterate or run that program that many 10 times. So I'm going to just make this simple here. I'm just going to do the logger.log, and what am I going to print? Well, I'm going to print, let's just print I. Let's just print what the value of I is, so we kind of see how this is working. So the first time through this for loop, I is going to be 0, so it should actually print 0 to the screen. And then it comes through again, and now it's incremented by 1, so now I is 1, and it should print 1 to the screen, and so on. So I'm just going to run that, and then I'm going to hit the return logger screen, and there it is. So it went 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it printed the I out 10 times, right? So now I can kind of do this. I can say, what if I wanted to do it, start with 1, and then I still wanted to do it 10 times, so I'd have to do less than like 11, right? And I can run that, and I can run it, and there it is, 1 through 10. Okay. I could actually do like I equals I, or I could do times equals 2. So what's that going to do? Let's try it. So I could run that, and I get 1, 2, 4, 8. So the first time through it was 0 times 2, right? So, or it'd be 0, and then the next time through it turned into a 1. Okay, and then it turned into a 2 because it took it times 2. Took it times 2 is 4. Took it times 2 is 8. And then it takes times 2 again. That's 8 times 2 is 16. And so that would not be less than 11. So that wouldn't work. So you can increment it differently too. We hardly ever do that, but you could. And there'd be reasons maybe to do that. Okay, so I'll go back to kind of setting up the way we normally had it. Okay, so there I printed out a list. So I could do something else. I could print out, let's print out like a binary thing. So let's print out a base 2 to the I power. So I could, if you remember how to do that, that's a math function, math.power, and you'll see it's x, and then there's a y value. So it's x, and x we're going to have be 2, comma, I. So this will go with every time it'll print out 2 to the I power. So the first time through, what'll it be? It'll be 2 to the 0 power, which is 1. Next time around, it'll be 2 to the 1 power, which is 2. Next time around, it'll be 2 to the 2 power, which is 4, and so on. So I can do the binary thing, up to 10 times. Whoops. Let's see. There we go. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. So I can do some different math on these particular things also. What are some other? There's a million things you can do with these for loops. So let's set up a variable. Let's set up an array variable. So var teams equals, and we'll do a square bracket because we're going to set up an array variable. So item 1, of course, are the ever important cardinals. Okay, comma, and then we'll do the Cubs out there for you Cubs fans that have now become Cubs fans since they finally won the World Series. Cubs. We'll do the Brewers. We'll do the Reds. We'll do the Pirates. Good enough. Okay, so here's an array of these things. And let's say we want to actually print out on the screen all of these in order. Okay, so how would I do that? Well, how many items do I have? I have 1, 2, 3, 4, 5. So what I could do is I could start with item 0, which will be this one, right? And this is item 1, 2, 3, and 4. So how far do I want to go to iterate through this list? I want to print each one out. So I want to go through less than 5, right? Because there's actually 5 items. So the way I can do that, I don't have to put 5 in here. I can actually do for I less than teams dot length. If you remember that, teams dot length is how long this array is. So teams dot length would actually be 5 because there's 5 things in here. So this is going to go through at 0, and that's going to go through 1, and then 2, and then 3, and then 4, and then it will not go through again. So what do I want to do? Well, I want on the log, I want to actually print, I want to print each team. So that would be teams, that's the array, and then I do, remember, square bracket and the index number. So if I wanted to do 0, that would print out cardinals. But I want to actually just print out, I want to put in I. Because the first time through, I is going to be 0, so that'll be cardinals. And then next time through, I is going to be 1, so this would print out Cubs, and so on. So I can hit return, and then I can do that, and Cardinals, Cubs, Brewers, Reds, Pirates. So it printed each of those out. Okay, so you want to analyze that code a little bit, make sure you really know what's happening there. This is, all this stuff gets confusing fast, really. So let's do one more thing here, something I could do that would be kind of fun. I could do a variable array called Rochambeau. You know what Rochambeau is? That's fancy word for the game rock, paper, scissors. So I could do rock, and then I could do paper, and then I could do the item is scissors. Let's say that's all the items. Okay, and let's say I want to run this game. I want to run the computer game like 100 times, and I want to see, so we're going to run the computer game 100 times. The computer's going to pick either rock, paper, or scissors 100 times in a row, and we can see what that looks like. So I'm going to do var I equals 0, and I want to do this loop for 100 times. So I'm going to do to 100, increment by 1. Okay, so what am I going to do in here? So well, I want the computer to pick one of these. So how do I do that? Well, that's going to be random, right? We're going to have to do random. And so I want either random 0, a 1, or a 2. So I'm going to do a variable, the number, well, we'll call it the index, equals, and then I want to do a random. So I'm going to do math.random. And what do I want to go up to? Well, I want to actually, I have 3 items. I want to do 0, 1, and then to 2, right? So I actually want to take it times, 3, because that'll be 0 point stuff all the way up to 1, and then 1 point stuff all the way up to 2, and then 2 point stuff all the way up to 3. And then I'm going to floor this, right? So math.floor, put that in there. Okay. I guess really before we do that, let's just test that. Let's print out our index. Okay, so it's going to go 100 times through this, and every time it's going to do a new index of hopefully a 0 through a 2, a 0, 1, or a 2. So we can just run that first and see if that's going to work. And there they are, 2, 1, 0, 2, 0, 1, 0, 0, 2, 0, 0, and did 100 times. Okay, so it looks pretty random. Okay, so instead of printing out that random number, we're going to print out either rock, paper, or scissors. So I'm going to do Rochambeau array, Rochambeau, and then I'm going to put the index as, index. So it's going to do Rochambeau like 0. If it does Rochambeau happens to be 0, it's going to be Rochambeau 0, be rock. If it happens to be a 1 here, that'll be a paper, and if it happens to be a 2 here, it'll be scissors. So I can run that. And there we go. Scissors, rock, 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 paper, rock, rock, scissors, scissors, rock, scissors, rock. Okay, all the way down. And maybe, later on we'll come back to this and we can make some kind of a game where a user might put in, rock, paper, scissors and click a button to run this game and have the computer pick something. You wouldn't have to do this 100 times. You only have to do it once. But the computer would pick something and then compare it, using conditionals, right? If else, can compare it to the one that the user picked and maybe print out a statement whether the computer won or the person won. So we'll probably come back and visit that game here in a little bit. So there's some secret code there for you to prepare for that particular thing. So this is how you do for loops. We're going to do that quite a bit, so that'll be hopefully very valuable to you. Okay, we have a JEDI task here to do. We're going to print out the results of 100 rolls of a die, a single die. You can't print 1 through 6, the numbers. You have to print the words 1 through 6 in your list. So you might want to think about how to do that, and go ahead and pause the video for a while and see if you can try to figure it out yourself. That'll make you feel better about yourself. And then you can unpause the video and see how we programmed it. Okay, so we have a function, and let's name it dice roller is our function, and we need to roll the dice 100 times. So we need a for loop, and we can do for, and we're going to do I equals we need to do a variable var I equals 0 for I less than 100 semicolon, and then we're going to increment I by 1 each time. There's our for loop. Okay, and then each time we need to roll the die, so we need to get a random number. So we'll call it die. No, we'll call it roll. How about roll die? There we go. Roll die. Whoop, we need var. Keep forgetting that. Var roll die equals, and then we know we do this with math.random. So math.random, and we need to take it times what? We need to take it times 7, actually. We need to take it times 7 so we can get 0 to 1. Let's see. Yeah. Okay, no, we're going to take it times 6, but we're going to add 1 onto it. So math random is 0 to 1, right? So if I take it times 6, that's going to be 0 to 6. And then if I add 1 onto that, that's going to be 1 to 7, which will be good. And it'll never be 7 because we're going to floor it. So right now, though, I could technically get a basically a 1 up to a 6.9999, something like that. So we're going to floor that. So math dot floor of all of this, and that should give us a 1 through a 6, I hope. Okay. Good. Okay, let's see. We need to set up a variable before we go into this for loop. We need to set up a variable, an array. So let's do var my dice equals an array of the words 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, close the array, semicolon. So here's our, because we can't print 1 through 6, we have to actually print the words. So I'm going to put all the words in an array here, and then I'm just going to access them. So I have var roll die is going to be a 1 through a 6. actually, so I'm gonna pull these numbers. Since I'm not doing 1 through 6, I'm gonna be pulling these out, and these arrays are gonna be numbered 0, 1, 2, 3, 4, and 5. So actually, I don't want to add 1 to it. I want to do math random times 6 because I have 6 things here. And I'm going to floor that. That's good. Yeah. So actually I need to do it times 7. So that'll give me 0 through 6 because I'm going to floor it. Yeah. 0, 1, 2, 3, 4, 5. No, I don't. That's wrong. Boy, got to work this out. I got to take it times 6 because I technically need 0 because I'm starting at 0. And I can floor that out to 0, to 1, to 2, to 3, to 4, to 5. Yeah, 0, 1, 2, 3, 4, 5. Good. Okay, that'll work. Okay, so then I can just do it log. So logger dot log. I need to do my dice and then the index number of the roll die. So if the roll die comes out to be like 1.7 something something, it's going to floor it down to 1. And then my dice item 1 is actually going to be a 2, so that'll work. Even though this is a 1, it's still going to be assigned as a 2. It doesn't matter. It's still going to be randomized. Let's see, is it just going to work or not? I got to probably put a semicolon there. Run. Uh-oh, sorry, I lost the internet. Better get back on here. Let's try to do that again. Oh, okay. So it tried to run, but it didn't run the right function. So up here, see, I have a different function. I have a dice roller. So I'm going to come up here and click run on that, so it runs dice roller because I renamed the function. So now I can do the log here. And what do we got? 2 1 5 1 3 3 2 1 3 1 5 1 2 2 2 3 6. There's a 6. Okay, I didn't think I was going to get one there for a while. Yeah, there's some 6s in there. Okay, there we go. I think it worked. Okay, so I run the dice 100 times. I assume it was 100 times. I could do this. I could do I could do plus 1. I plus 1. Since it's starting with 0, I want to add 1 onto it, so it'll be like it'll number it correctly like normal. Plus, let's do dot parentheses space. Okay, so now I'm going to number every roll. I don't know if that's going to work or not. Well, let's just run it and see. No, missing after argument list. I wonder if I have to put that in. Let's try to put I plus 1 in parentheses. Will that do anything? No. Let's just do I. Oh, never mind. I plus 1, and then I need a plus here. Yeah, you got to concatenate things by doing plus signs. Let's see what that did. There we go. So now they're numbered. Roll 1 was a 3, roll 2 was a 2, all the way to roll 100 was a 1. Okay, just kind of play a little extra in there. Didn't need that part in there, but we did. Okay, so let's see, what do we got here? That's like 1, 2, 3, 4 lines of code basically in our function. Okay, so hopefully you maybe figured out something like that. All right, in this JEDI task, we're supposed to print out the results of 100 flips of a coin. We're going to print heads or tails each time. And at the end, we're going to print out the total heads and we're going to print out the total tails. So you can pause the video at this time and try to think how you would do it, and try to code that, and then you can see how I did it and see which one of us won with the least amount of lines of code. So go ahead and pause and then figure it out. Okay, if you're back, we're going to start our function here. I'm going to call my function coin toss. If I save it up here, so now up here instead of my function will be my coin toss instead. Let's see, we need a for loop because we're going to do something 100 times. So I'm going to do for, set my counter I to 0, and then we're gonna I less than 100, so we'll do it 100 times, and then increment I by 1 each time, and then okay, so now I got a loop that'll do something 100 times. Okay, so what do I want to do 100 times? Well, each time I want to flip a coin, so I'm gonna have to do we'll call it coin equals, and I want to do it random, so I'm going to do math.random, and that's going to give 0 to 1. I actually want to take that times 2 because I want 2 options, so I want it to, and then we're going to floor that, so math.floor that, so that'll end up giving me a 0 or a 1, basically. That's it, 0 to 1. Because anything like 1.999 all the way up to 2, is going to floor it down to a 1. So, yeah, so that's going to give me a 0 or a 1. All right, good. Let's go up here and let's, well, there's 2 ways I could do this. I could do it like I did the roll the dice, and I could make a variable, an array variable that had the words head and tails in it. But what I'm going to do is, there's only 2 things here. I'm going to actually do an if statement here on this one, so we can practice our conditionals. So I'm going to do if coin. Whoop, I didn't do a variable there again. Sorry. I gotta remember to do that. You don't have to do this in some other languages. That's why I keep forgetting. So if coin equals, remember it's equals. If coin equals 0, okay, what are we going to do? We're going to say that let's come up here and set a variables. Let's see. Well, actually, what we could do, let's just do it this way. So if coin equals 0, let's log that. So logger dot log. Let's just say it's let's say it's heads. No, let's say it's tails. 0 should be tails, right? Tails. Okay. Good. So if coin equals 0, log tails. We need else. So else it's going to be heads, right? So if it's a coin is equal to 1, it's going to be heads. But we don't need to say else if it's equal to 1 because that's the only other option. So heads. So if coin is 0, tails, else, print heads. Okay, good. Now, maybe we should just run that real quick. Let's try it. So run it. Okay, so I'm missing some stuff. What do I got? This is the, okay. Oh, whoops. I need another bracket. And you got to keep these brackets straight. See, here's the first bracket, open bracket and closed bracket of my function. Here's the open bracket of my 4 and the closed bracket of my 4. And then I have an open bracket of the if and an open bracket and close bracket of the else. So there we go. I was missing a thing. So we do it, and tails, heads, heads. Okay, we got a lot of list of tails and heads. That's all good. What other parameters were in this program? At the end, we're supposed to print out the total heads and total tails. Okay, so what I want to do is before I even get into the for loop, we're going to set up some variables. Var heads equals 0. So these are just counters. And var tails equals 0. There's some counters for us. Okay, and so if coin is equal to 0 and logger.log tails, I also want to update the tails count. So I could do tails plus plus, right? I could do tails plus plus. I could add, that's going to add 1 to the tails. And then down here, I could add 1 to the heads plus plus. Okay. All right. So here's outside of my for loop, and so when I get all the way done, I can do this 100 times, and basically it's going to count up my tails and heads, and it's also going to print tails and heads. At the end, though, I could I'm going to have a total heads and total tails, so I could do logger.log and I could do a string. I could do heads space plus concatenate the heads plus tails concatenate tails. Okay, so it should say heads and how many there are, and tails how many there are. Okay, moment of truth. Let's run this baby. Heads, tails, heads, heads, heads. There's a lot of them, and whoa, heads 50, tails 50. That's like perfect. Okay, does it always work that way? Let's run it again. Run it again and look at the log. It did. It worked. Run it again. Look at the log. There we go. 47.53. See, it's random, so it shouldn't always be 50-50, but it should always be kind of, you know, fluctuating around that. Run it again. 56.44. I'm just curious. We should just run like we should put this whole thing in 1,000 loop and see what's the biggest difference we ever get. That'd be really interesting. Put this whole function in a bigger loop and see. Ooh, look at that. That's crazy. That was way distorted. 38 heads and 62 tails. That's like an unlucky thing there. 44.56. Okay. All right. I've had enough fun. So there's your coin toss. You might have done it a little bit differently, but that's good. You can be creative in how you worked it out. As long as you got the thing to function the way it was supposed to, that's the goal. Learn, learn, learn. All right, in this JEDI task, we're going to do make a program called FizzBuzz. This is actually kind of a classic, simple program that a lot of times if you're looking for a job in some kind of coding or technical skills, the first thing they might do is just say, they might just give you this quick little program, you know, program how to do FizzBuzz. Basically, it's a really quick little program to weed out people that actually know how to code and people that don't. So here's your big trial here. If you kind of Google FizzBuzz, you'll see a way to program FizzBuzz in lots of different languages. But you should try it out here and try to figure it out on your own before you kind of start looking around. So the task is to print out a list of numbers, and we're going to go ahead and just go from 1 to 100. And if the number is divisible by 3, then we're going to print fizz instead of the number. If the number is divisible by 5, we're going to print buzz instead of the number. And if the number is divisible by 3 and 5, we're going to print FizzBuzz instead of the number. So that's how it works. Those are the parameters. And if you want to go ahead and pause the video and try to figure it out and see, and then come back later and see which one of us did it in the least amount of code. Okay, so if we're gonna start this, I'm gonna call my function FizzBuzz. Okay, I'll save that so that I have FizzBuzz up here in the drop down that I can run it. Okay, so obviously, what do we need to do? We're gonna have to do something 100 times because we're gonna do we're gonna print out the numbers 1 to 100. So let's just start and do a function that would actually do that. So obviously, I need a for loop, so I'm gonna do a for. I'm going to set up a variable I. Normally we start with a 0, but actually we're going to just do the numbers 1 to 100, so I'm actually going to start it with a 1. And then I'm going to do I less than or equal, I'm going to do to 100, right? So now it's going to do I all the way up to and including 100. So I'll put a semicolon there, and then I'm going to increment that plus plus. Got my for loop. Okay, so so I could do I could just do logger dot log I. That would actually print out the number 1 to 100. Let's go ahead and just run that, and it's always good just to stop your code and just see if you know where you're at. So I'll do run, and then I'll run that, and I have 1 through 100. So that's good. Okay, so now all I have to do is I have to think as I go through each one of these loops here, I have to determine if the I is actually divisible, completely divisible by 3, 5, or both. So how would I do that? Well, I'm going to do if else. I'm going to do conditions, right? So I'm going to do if, and I'll do the first condition, and the first condition probably should be the FizzBuzz one. So, because if something's divisible by 3 and it's divisible by 5, then I want to replace that with FizzBuzz first, instead of going like the 3 one first, because that'll kind of mess things up. Because if I replace 3 with fizz, like for instance, like let's take the number 15. Is 15 divisible by 3? Yes. So I might replace it with 3. But or with fizz, sorry. But the problem is it's also divisible by 5. So technically it's supposed to be replaced by FizzBuzz. So we need to check all the numbers that are divisible by 3, or if the number is divisible by 3 or 5 first, and then we can do the other two. So how do I know if a number is divisible by, perfectly divisible by another number? Well, you know that if the remainder is 0, right? When you divide a number by another number, if it's completely divisible by it, that means the remainder is 0. It goes in a perfect amount of times. So there's, if you remember when we did operators, there is an operator we can use to get not the answer, but the remainder. And that is the modulus symbol. So it's a percent symbol. So I'm going to say if I modulus percent 3, right? So if modulus, so if I divided by 3, and I don't want I divided by 3, I want I, what the remainder is from I divided by 3. And so the symbol is not the slash. If I just do like slash, that's I divided by 3. But if I do I modulus 3, that's taking I divided by 3, but it's only returning the remainder to me. So if I modulus 3 equals 0, and how do I do an and here? So remember it's and. And I modulus 5 equals 0. So if you take I divided by 3 and the remainder is 0, and you take I divided by 5 and the remainder is also 0, then that means we're going to do what? Well, that means we're going to print FizzBuzz. So I can do that in here. I'm going to execute this code, logger log FizzBuzz. Whoops. FizzBuzz. There we go. Okay, so now I need some else's, right? So I need to do else and then if, because I need to do another condition. Else, if I modulus 3 equals 0 only, then I'm going to print fizz, right? Another condition, else if I modulus 5 equals 0, okay, then I'm going to print buzz, What else? Well, that's it. So else, I need another else. I'm going to just print the number. So it comes through here. It goes 100 times, and if I divided by 3 is 0, and the remainder is 0, and the remainder of 0 is if I divide it by 5, then I'm going to print FizzBuzz. If the remainder is 0 when I divide by 3 only, it's going to be Fizz. 5 only, it's going to be Buzz. Otherwise, I'm just going to go ahead and print out what I is. Okay, so we'll try to run that. Moment of truth. What do you got? 1, 2, and then instead of 3, it was a Fizz. 4, 5. Instead of 5, it was a Buzz. Fizz. 7, 8. 9 is Fizz. 10 is Buzz. 11, 12, 13, 14. Look at that. 15. 15 is FizzBuzz instead. Okay, and this here's 29. This is 30, and then this is 45. And so, if you think about that, technically, I guess we're going to print a FizzBuzz when anything is divisible by 15, right? Because it's divisible by 3 and 5. That means it has to be divisible by 15. So all these FizzBuzzes are going up by increments of 15. So I guess to shorten the code up a little bit, I didn't have to use this and. I could have just done if I modulus 15, if I divide by 15, if the remainder is 0, I could just take all the rest of this out. And that should go ahead and work right there. We'll try it again just to make sure, but yeah, same thing. Okay, so that's how you do FizzBuzz. Okay, in this program, we're going to write a program that will print out the Fibonacci sequence up to the 100th number. We could change that and make it print up to anything we want, but we'll just print it up to the 100th number. The Fibonacci sequence, if you don't know, is a really important sequence. We find it in nature and all kinds of places. And here is the beginning of the sequence, and even if I don't tell you how it works, you might be able to kind of notice the pattern here. We start with 0 and then a 1, and then the pattern just continues on by adding the previous 2 digits. So if I have 0, 1, and then I add those 2 digits, I get a 1. Then I add these 2 digits, and I get a 2. I add these 2 digits, I get a 3. Add these 2 digits, I get a 5. Add these 2 digits, I get an 8. 13. Plus 8 is 21, plus 13 is 34, plus 21 is 55, and so on. So we really just need to add up the first 2 digits each time to get the new digit and keep going from there. Okay, so I'm going to do this, or you might want to pause. You want to pause this and try to figure it out yourself first. And you can Google this and know how to do it, but there's lots of different ways to do the Fibonacci sequence. People have tried to get the best algorithm to print it out in the quickest amount of time and so on, but it's not cool unless you can figure it out yourself. So try to because your method is going to be just as good as anybody else's. So go ahead and try to figure out how you would do the Fibonacci sequence, and then pause the video and then come back as soon as you got it figured out. Okay, so hopefully you're back with me now, and I'm going to change the function to Fibonacci. And we're going to need a loop, to do this a whole bunch of times because we're going to print it out each time. But what I'm going to do before I start my for loop is I'm going to go ahead and set up a variable. I'm going to do a var and a. I'm going to keep this real simple, var a, and that's going to be my first digit. So I'm going to do 0, and then I'm going to set up another one, var b. And I'm going to have that be equal to 1. That's my next, my next digit. Okay, that's kind of sets it up. So now all I have to do is keep adding it all together to get my next digit. Okay, so I'm going to I'm going to do a for loop, and I'm going to start with, I need to do this like 100 times, right? So I'm going to, I'm going to I'm going to go ahead and print those to the screen right there. So logger.log A, and then logger.log B. Ugh. There we go. So that's going to print out 0, and that's going to print out 1. Okay, so so how many more times do I have to do it? Well, I'm going to do it 98 more times, right? Because I need to print out all the way to the 100th one. So I'm going to do var I equals 0, I less than 98, right? Because I want to do it 98 more times. And then I plus plus, there we go. Okay, so I got my for loop set up. So I need to figure out how to every time print, you know, a new thing. So so what I want to do? Well, I want what is the new thing? Logger dot. Well, what I can do is I can get the let's get the new thing first. So the new thing is going to be we'll set up another variable C. And variable C is going to be the new one I want to print, and that's going to be equal to what? It's going to be equal to A plus B, right? So I add up the two right before it, A plus B. It's going to be C. And then I can go ahead and put that on the screen, logger.log C. Okay. Now, if I go back around now for the next time, C is not going to change because A and B are still 0 and 1. So I need to, every time I print off C, I need to change A and B to the previous thing. So so what's A going to be now? So A is going to be what B was, right? So it was 0 and 1. So now I want my A to be what B was. So I'm going to do A equals to B. So now A will be 1. And what should be B? Well, B will be equal to what I just printed to the screen, right? B should be equal to C, okay? And so now, if you think about this, so A is going to be equal to B. So now A is going to be 1, right? And B is going to be equal to C, which of course is a 1, right? So now the second time through, A is going to be 1 and B is going to be 1. And when I do that, I'm going to get C equals A plus 1 is going to be 2. So C now will be 2. And then we reset everything again. So that, I think, should work. That's one method. Let's try it. So we're going to run it. What do I have? Oops, script function not, okay. So I need to make sure I'm on Fibonacci. I need to click the run thing up here, I guess. Okay, and then we'll log it and we'll see. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Looks like it worked all the way down to, ooh, look at this. The numbers are getting so high that it's putting it in scientific notation. It's saying 2.189 times 10, E is times 10 to the 20th power. So it's pretty crazy. It got way, way up there. Really, really fast. Okay. All right. So there are other methods that you can use on this. One of them is called recursion, which means you make a small little function and then you call that function within itself. You would actually, you're just kind of functioning all the way in the whole time. So that's one method. We haven't really talked about that. We probably won't get that complicated. So so there's my code for Fibonacci. I don't know if it probably might be a little bit different than what you come up with, but that's one way to do it. Hopefully you had some success on that.